So make sure we can put an equation into slope-intercept form. So I kind of gave you an example of that. Sorry. Okay. These are your steps for graphing. You're going to have to graph one line or two lines. And you have to also do inequalities. So it says right here, find the y-intercept. Your y-intercept is the b. That's what this illustration is over here to the right. So our y-intercept on number 12 is 4. So you have to plot that point. Then it says, from the y-intercept, use the slope. The slope is always, when it's in slope-intercept form, the number in front of x. So my m here is a negative 2 over 1. I want to write it as a rise over run. So I put my pencil on this y-intercept. A negative 2 means I'm going down 2 and then to the right 1. And then we just join the 2 points. This is all it'll ask you to do, join at least 2 points on Alex as well. So if I was graphing number 13 here, we would start with the y-intercept, which is a negative 1. And the m, the slope, is 1/2. So that means I'm going up 1 to the right 2. Now, part of this section is dealing with systems. And if you have two lines that intersect, that intersection is the solution. So that's just recapping that. We're going to do that again in section 4, but just make sure if you're graphing two lines, the point of intersection is your solution. Most likely, they're going to give you the equation in standard form. So it steps here, it says move the ax term. So that means I would have to do that by doing the inverse. So on 14, you have to subtract the 2x, leaving you 7y equals negative 2x plus 1. And then step 2 says divide everything by the b. The b is what's in front of the y. So we're dividing each term by 7. Y equals negative 2 over 7. Sorry. X plus 1/7. You got to be able to get it into slope-intercept form because this is how you graph. And most of you can do the graphing. Like I'm not going to specify what method, but you have to be able to get to the slope-intercept form to graph. So here on 15, you would minus 5x first. Don't forget your sign. So this is a negative 3y equals negative 5x plus 15. And then you would have to divide everything by a negative 3. So y equals a positive 5/3 x minus 5. Okay, so for your types of lines, we need you to make sure you understand parallel, perpendicular, neither. If it's parallel, they have the same slope, okay, but a different y-intercept. So the slope is the same, but the y-intercept is different. For perpendicular, you have opposite reciprocal slopes, and I'm just abbreviating that. This is when you flip the number. So you flip number and change sign. The y-intercept is also different. Now, if it's neither, that means two things could happen. Maybe it's just a different sign or opposite sign, or maybe it's just a reciprocal. And again, the y-intercept's going to be different. So an example of the graph, parallel lines, oh, that doesn't look very good, but they should never cross. If they're perpendicular, it should make a right angle. So they form a right angle. Intersection, I'll put that in there. The intersection forms a right angle. If it's neither, then you can just have one increasing and the other one decreasing. So they just intersect. That's all they do. Okay. If it's neither, it's just an intersection. The other types of lines I forgot to put on here is, don't forget horizontal. If it's horizontal, it's y equals the number. And you have vertical lines. If it's vertical, it's x equal the number. So, bucks. Okay. Vertical is undefined, horizontal is 0. Okay, so then basically this is, I'm kind of sharing the problems y'all had to do on the online part. This percentage was low. So in order to determine if they're parallel, we have to look at their slopes. And the best way to see the slope is in mx plus b form, because the m, this is our slope. So if I don't see the number in front of x, we have to remember that's an invisible 1. So here the slope is 1, sorry, negative 1. So for the perpendicular, you have to flip this number and change the sign. Well, if I have a negative 1, that's the same thing as saying negative 1 over 1. If I flip it, well, that's 1 over negative 1, and I change the sign, it's not negative anymore, it's positive. So this is just a positive 1. The parallel is going to have the same slope. So it's going to be negative 1. Now, on a problem like this, it's not in slope-intercept form. So you have to minus the 2x. I'm just going to rewrite it over here. That's 7y equals negative 2x plus 1. Then you have to divide by 7. So the equation is negative 2/7 x plus 1/7. The slope is just the number in front of x. So the perpendicular would be 7 over 2, and the parallel is the same number, negative 2 over 7.
Yes.
All right, so our last section, or last 2 sections, is doing systems. This is just when you have, if it's a system, you're going to have 2 or more lines. So I'm not going to say you have to use one of these, a specific method. It's just a review of the different types. We can graph, looking for the intersection. we can single out an x and y and plug it in, or we can line them up and try to eliminate. This is just 3 methods. If I'm doing the graphing, we would start with the y-intercept, -4, then move the slope. So pencils on -4, that's going up to the right one to create that line. Then we're graphing the second equation. So y-intercept is 3. The slope is a -1/2, so down 1, to the right 3. Oh, sorry. And then, oops. This intersection is the solution. That happens at the point 3, 2. So the answer would be 3, 2. (19) is an example of using substitution because the x is isolated. So we take what it equals and plug it into the first equation. If you do substitution, you have to use parentheses. So this would be 4 parentheses -2y plus 6, then minus 3y equals -9. Now we're solving for y, so we have to distribute. -8y plus 24 minus 3y equals -9. We're going to combine these like terms. The y's become a -11y. We're going to isolate the 11y. Doing the inverse here. So my -11y is going to equal to a -33. Divide by that -11. Our y is 3. Once we have the y, we have to plug it back and get the x. So this is basically saying -2 times 3 plus 6. Well, this is a -6 plus 6 is, this turns into 0. This is your x. So your order pair, your answer here is 0, 3. -6 plus 6. Elimination, this is when you have to have your x and y's lined up and you want them to be opposite. So if my x's are opposite, here's the negative, there's the positive. But something happens on this one. This is a special case because the x's cancel, the y's cancel, and the constants cancel. So if you have 0 equals 0, which is true, if everything cancels, then this would be infinite solutions. If you, yes.
What happens if have a equation like that and you cancel out to where you have, like, for instance, a y, but your x's cancel out and the equal sign cancels out?
Wait, you mean this cancels out?
Yeah, if that x canceled out and then the x canceled out, you still got a y.
So you still have a y. So if you still have a y,
yeah,
it's the y equals 0 because this is canceled, right?
Yeah.
So that means y is 0.
Oh, okay.
Mm. All right, so we got two more examples to look at. For example, on 21, the y's could cancel here if they were opposite. So you would need to first multiply the top by -1. So we get -2x, now -2y equals -6. The bottom is going to stay the same. 4x plus 2y equals 12. We add them to cancel the y's. We're adding the x's, so now we have 2x equals, we're adding up our constant, that's going to be a 6, and so x equals 3. Now we just have to plug it back into one of the equations. It doesn't matter which one. I'm going to just do the top one. So that means this is going to be 2 parentheses 3 for our x plus 2y equals 6. Well, this turns into 6 plus 2y equals 6. So I subtract the 6. Now I'm left with 2y equals 0. So if you do any number, 0 divided by any number is just 0. So our answer is 3, 0. So same situation. Nothing is opposites here. The x terms are not opposite, the y's are not opposite, but I can make the x opposite if I multiply the top by a -2. Because now I get a -10x minus 4y equals -14. I'm just rewriting the second equation. Now this is another special case. Because here the x's cancel, the y's cancel, but the constants do not cancel. This is getting me 0 equals -17, which is a false statement. And anytime we have a false statement, we write no solution. So like if you wanted to solve this by graphing, if you were to graph, this would be parallel lines. If there's no solution, you have basically parallel lines. If it's infinite solution, you have the same line. So like on the one that we did on the front page, sorry, here, because this is infinite solution, you would have a line drawn and the exact same line on top of it, so that you would have the same line. So like if you're using the graphing method,